This podcast is sponsored by Click Playground. This free programming environment lets you explore and test your data-driven app ideas using Click's engine and APIs. The goal? Less query writing and more efficiency with associative indexing. Visit playground.click.com to learn more and see it for yourself.
Hello and welcome once again to the InfoQ podcast. My name is Wesley Reisz and I'm your host. In addition to hosting the InfoQ podcast, I get the privilege to chair the QCon software conferences in London, New York, and San Francisco. Both QCon and InfoQ are designed for senior software engineers and architects. If you don't know us, I hope you'll take a few minutes to check us out. You'll have a great time. You'll learn a lot. In this edition of the InfoQ podcast, I'm chatting with Nora Jones. Nora is a senior software engineer at Netflix, where she works on chaos engineering. Prior to Netflix, Nora worked at Jet on developer productivity, which also included some work with chaos testing. Today, we talk about the conversation around establishing rigor with chaos engineering. We talk a bit about a book that she co-authored with some other folks at Netflix. We discuss kind of a process around doing chaos engineering that includes experimentation, starting with a hypothesis and going through tests and evaluating those tests. We'll talk more about those things. And then we dive a bit into actually how to introduce chaos experiments into your environment and much, much more. Thank you for joining us today. I hope you really enjoy this podcast. Nora, welcome to the InfoQ podcast.
Thank you. Great to be here.
You just moved from the East Coast out to the West Coast to join Netflix, right?
Yeah, exactly.
How's that move been?
It's been great. Definitely different mentalities in the East Coast and the West Coast, but I'm really liking it so far.
I mentioned in the intro, your career's been a lot about chaos engineering. How did you get started in the field of chaos engineering?
I started my career at a home security company. It was focused on home security and home automation and sort of how those components interact together. Like if you trip a door sensor, if you trip a video sensor, like should the door lock, should the alarm go off, those kinds of things. So there, my role was focused on creating different scenarios that could happen with all those different moving pieces interacting. Through that, I would create different failure scenarios as well. We weren't exactly calling it chaos engineering at that time, but that was sort of how I led into this field.
What did those early days of chaos engineering look like? What were some of the types of things that you were doing there?
I was essentially creating different failure scenarios. I had this whole rig set up at my desk. It was a hardware-based company, so I would trip these sensors automatically. I'd have a light bulb on an automatic timer like go off and trip a camera sensor and then have that in turn trip the alarm. I'd have expectations in place with what would happen, but I would also record things that, weren't expected and kind of see where the different failure scenarios led. If it failed when it was expected, if it didn't fail.
And then that bridged you over into developer productivity at Jet. You kind of built the team there, right?
I was the first person hired to do developer productivity at Jet with the mission, enhance speed of productivity, make things better. When I joined Jet, it was very, very much in startup phase and weren't a lot of engineers at the company, but it was at a phase when the site was going down pretty regularly, as happens with startups that are moving at lightning speed. So I was trying to help mitigate that in some regard, trying to reduce hours spent on mitigating failures, engineers waking up at 2 a.m. And so I started doing that through chaos engineering.
I was going to ask, when I think of developer productivity, I think of a lot of things, and chaos might be one of them, but it's probably not the very first thing I come to on it.
It kind of seems like anti-productivity at first.
Yeah, it does. So I guess the conversation these days is around chaos engineering, but I guess I'm used to hearing it just chaos testing. Why is it chaos engineering now and not chaos testing?
Chaos engineering is the discipline as a whole, but when you're creating individual, as you would call them, tests, we like to call them experiments. So if you think of how testing is described now, it's sort of binary. Either it passes or fails, but it doesn't create new knowledge. It just determines a known property or what you think is going to happen, right? It determines whether or not the user's expectations happen or not. But with chaos experimentation, you're sort of in a new space, right? You have a formal method to generate new knowledge. You have a hypothesis and you're trying to do something and then you see what comes out of it. And then if your hypothesis isn't supported, then it's a form of exploration. That's sort of the experimentation aspect of things.
When you moved over to Netflix, you co-authored a book you talked a bit about the rigor around chaos engineering, and you mentioned the things you had. I found it really interesting that it is an experiment. You start with a hypothesis, and then you go through a variety of steps. Could you talk a bit more about those process and why you all felt the need to establish this rigor around the discipline?
So it was sort of through our own experiences. Mine having been at different companies, theirs having been at Netflix. Like Chaos Monkey was nice because it randomly killed things and it found a lot of stuff, but they also had this monkey called Latency Monkey, which would just go in and make things latent. And it caused a lot of issues because there wasn't like a big plan around it. There wasn't hypotheses around it. There wasn't scope to it. There wasn't any safety mechanisms to maintain the customer pain. And it could cause more harm than good in those kinds of scenarios. So chaos engineering has a lot of benefit as a whole if it's handled properly. But if you don't scope it out properly and have a strategy behind it, it could get out of hand and again, cause more harm than good. So we felt the need to define a process like based on our experiences with it so that other people that are just getting started with it can start off on the right foot.
Can you give me an example of what a good hypothesis looks like in the context of chaos engineering?
Yeah, if you really think of like how you create a scientific experiment and scientific hypothesis too, that's sort of what we're applying here. Like if X happens, then I expect Y to happen. So that's something that we try to say before a lot of the experiments we're running, especially in the beginning stages. You know, when we were sitting down with service owners and creating these experiments and sort of arbitrarily creating them to an extent, before we ran them, we said, what do you think should happen here? And, you know, the most bare bones answer is we expect to be resilient to this. If you don't expect to be resilient to it, then you really want to be careful when you're running that chaos experiment, right? Like run it at a time when you know your engineers are on call. Make sure your blast radius is kept in check there and there's a good safety mechanism there. But injecting latency in those critical services or ones that you don't expect to be resilient to, that's a good step rather than failing them. But yeah, in terms of hypothesis, like if we fail a call from service A to service B, then we expect the fallback path to kick in, right? And so if that fallback path doesn't kick in, then what happens? And so that's sort of the interesting path I think you go down after that. One of the other interesting paths is like, say service C is not a critical service, or so we think, and we're failing calls from service C to service D. And we don't expect it to be critical. We don't expect it to affect our core business metric. So that's our hypothesis there. If I fail these calls to this non-critical service, then I don't expect, you know, our core business metric to be impacted. And if it is, then maybe this service is critical and you didn't even realize it. You know, we like to call that surprise. You actually have a tier 1 service. You know, people like to define those on their own. I've noticed in a lot of companies, you'll have so many microservices, like hundreds and hundreds, and you're like, yeah, these ones are tier 1. Yeah, these ones aren't. It's like, how do you know that? Right? Like, how does anyone know that? Have you empirically decided this, or is this just what you want it to be, right?
Let's talk about this. How do you go about creating a strategy for chaos engineering? You've obviously done this at least 2 companies now, so it's some flavor of this, and then join Netflix with it. How do you go about establishing what a strategy and kind of setting the boundary of what you're going to be doing and offering kind of that safety net to get started?
Yeah, this is one of my favorite questions, actually. You really, really have to keep your business goals in mind. And with that, you have to align with your business owners, your service owners, and stakeholders in any regard. Like as the chaos engineer, as the person that's kicking off these experiments and sort of creating the strategy around it, I think you need to answer a few basic questions like, what's your business goals? What are the KPIs that monitor these business goals? And what's the cost of impact if these KPIs get impacted in some regard? And so when you're at a home security company, like the cost of impact could be related to if someone can't lock their door, you know, that's a very high cost of impact in regards to safety. At an e-commerce company, if you're just getting started and you're just getting customers on the site, if they see the site down or if they're not able to add to their cart or something, you might just lose a customer in general. So what's the cost of acquiring a customer? How much money are you actually losing like by that being down? At a streaming company like a Netflix, a lot of your customers are already signed up. So what does it take to actually get them to sort of leave the platform or stop watching? So understanding that customer mentality there. And then if there's issues that are going on around the site that are already causing those things, those are where you want to start with chaos engineering as well. Sort of recreating those issues in a means that make you more prepared for if they happen or help you design around them and develop around them.
How do you answer someone who says, this sounds great, but let's only do it in staging or in test or in a dev environment? Is that a good first step? Is that good enough?
I think it's a great first starting step, and that's how I started at Jet. One of the first chaos experiments we ran actually ended up taking QA down for a week. So I'm glad we didn't end up taking production down for that long a time. And it did uncover some issues that were previously unknown.
Yeah, I think we all have a few stories like that.
I think the way distributed systems are nowadays in microservices architectures, it's impossible to keep your staging and QA environments exactly like production. If you are doing that, I definitely want to talk to you because that's really cool. But I think it's impossible to get a full idea of how the customers are interacting with it via live traffic, via all these other things that are going on in production that aren't necessarily happening in QA. You can't get a completely accurate feel. So you can uncover some issues, and those will be great, and it's a good starting point. Like while you're trying to manage your chaos and the safety of it, it's a good starting point from the chaos engineer's perspective and also the company's perspective. And then I think once you get that underway, it's important to do testing in production. And Charity Majors actually released a great article recently on like why you can and should be testing in production. And I think it highlights a lot of these points.
What's the most common argument you hear about moving these tests, these experiments into a production environment?
I like to refer to this as like, this doesn't apply to me fallacy. So like, people look at Netflix doing this and they're like, oh, this is a streaming company, right? Like if you fail, like someone can't watch their videos. But there are a lot of companies doing this. I know of banks doing this. There's automotive companies doing this, companies focusing on self-driving cars that are doing this, like Polysync. And JPL is doing this, and ING, and Capital One. So there's a lot of high cost of impact companies that are doing this. And I think the common fear when you have a high cost impact company, if your KPIs get hit in some way and it very much impacts your business goal in terms of cost or safety, I think there's an implicit fear among business owners and service owners that we shouldn't be causing more harm than we need to. But with the practice of chaos engineering, causing little bits of harm over time will reduce that giant harm in the future. Will reduce our time spent mitigating it, will reduce the chances of it happening, and injecting a little bit of failure over time is going to make your system more resilient in the end. And so I think having that culture shift is sort of the hardest part of getting started.
Yeah, definitely. I think it was Colton Andrews who said this, but it said it's like an inoculation. It's like building up your immune system to a flu virus or something.
Yeah, I also like to think of it like flossing. If you just started flossing, your gums will bleed, right? But like over time, your gums get more resilient to it, and it's actually good for you, right?
Yeah, it sounds like a good title for a talk that's coming up. All right, so we talked a bit about kind of the rigor, the process, the conversation. One question I have is, how does chaos engineering today, the discussion that's going on with chaos engineering, how does that fit into the larger SRE story?
I think there's a place for it within site reliability engineering. I think a lot of people are practicing it now, but they aren't placing as much focus on it as Netflix is or as Jet.com is or as a few other companies are. I think as distributed systems get more and more complex and more distributed, there is a higher need for chaos engineering. You can't, as a human, hold all those interactions in your head, and you can't understand the connections between different moving components. And I think chaos engineering kind of helps you sleep at night as a site reliability engineer or someone that's going to be on call, knowing that these issues are taken care of and knowing that you don't have to hold all that information in your head.
I guess let's just put this in context so that people can think of some real examples. As you're getting started, is creating a cron job with Kill-9 enough to get started? What is an experiment? What is a test that is a good first step that you might use?
Kill-9 is great. It's good to run for stateful applications, and you'll directly see what your impacts are. I actually know that AWS and VMware both implement Kill-9 on the back end. It's good because it's harsh, but the cleanup could be very, very complicated. So it's important, again, to know what you're testing there and have a strategy around that. I wouldn't build my whole chaos program around that, but I do think it's a good starting point, along with, terminating instances like a chaos monkey. There is a little bit of randomness to it, but as long as you're strategic about that randomness and letting people know in the beginning exactly what you're terminating and allowing them to opt out, I do think is important. But it is a good first step, especially with stateful applications.
Okay, so you mentioned like a good step for stateful applications. Let's do an example. Say I have some kind of shopping cart application. It's a microservice environment. It has, we'll say 15, 20 different services that are there. Not using chaos testing, and we asked you to come in to start to build a program around it as the first chaos engineer. What types of questions do you have or would you have for that? And what might be the kind of first steps for that kind of application?
I would start with the service that calls all of these things that eventually gets to the shopping cart. I would start by injecting failure between that and its immediate children calls.
Okay, but when you say failure, what do you mean? Is it just drop packets? Are you talking about drop orders? Are you talking about latency? What does that mean?
When I think of chaos engineering in terms of interacting components, I think of injecting failure and injecting latency between calls. So injecting failure between calls could be as simple as throwing a random exception between two services. Injecting latency between calls could be as simple as like adding a timeout in your code as well.
Very cool. So when you talk about injecting the failure, throwing random exceptions and latency in there, is there a specific set of frameworks that you're talking about? Are you literally just talking about wrapping an if block that has if doing failure, then do this on some percentage random value or something?
Yeah, exactly. It could be that. You want to have a few checks in place. Like it could be something you inject in a function level. It could be something you inject in class level.
So you're talking code, though. We're not talking like CHAP or some program that actually sits outside of the actual code base. You're talking about code written into it.
Yeah, so CHAP sits on top of FIT, which is a failure injection library. So there will need to be some code added to an extent, but it's not a ton of overhead. And you can make it so it's not a ton of overhead. You could make it so it's just engineers adding, a library file or just adding something to their functions. I actually have like a sample repo up on GitHub that allows you to play around with this. It's a very high level failure injection, but it allows you to play around with injecting failure and latency into your function level to an extent. So I would think of it in terms of that.
Another thing that you mentioned in the chaos engineering book was the chaos maturity model. What is the chaos maturity model?
Yeah, so Netflix had a big success with Chaos Monkey and Chaos Kong, and those tools allowed them to get sophisticated in terms of the technology behind them. And also the adoption was very high too, right? So if you draw an X and Y axis with sophistication being on the Y axis and adoption being on the X axis, they were both very high. It was sort of like in the top right corner of that graph. And so we started thinking about our new tools, like one of them being CHAP, our chaos automation platform. So CHAP essentially builds on top of a failure injection library and decreases the overhead needed for engineers to adopt this. It also reduces the blast radius to an extent. So if you're looking at your main customer metric or your main business metric, like for example, for Netflix, we use SPS or starts per second. So if someone's not clicking play in a given second and we have this expectation of, okay, here's how many plays we expect to be happening at this particular second at this moment in time. And if it gets too far deviated from that line, that's when we stop the experiment. So CHAP is focused on like reducing customer pain. And it still is enough to give us a signal like, hey, this could actually cause a problem, but it stops it before a customer gets unhappy, before we cause alerts to go off. And then it notifies the engineers, hey, this particular experiment caused a problem. And something that we're focusing on right now with CHAP, in its current state with CHAP, you have to decide your starting service and then what you're failing calls to. So if you're failing calls from service A to service B, or if you're making calls from service A to service B more latent, you have to put that in there. At its current state, it kind of requires the engineer to think of exactly what they want to happen. And right now we're actually focusing on making this more automated. Really all you have to do is put in a service and it will find all the immediate children. It will find different architectures it could go down. And it will sort of create the experiments on its own. And then as a user, you can approve or reject those experiments, whether you want them to run. So that's something that we've been focusing a lot on this quarter.
So CHAP isn't open source, but what are some of the ideas that you've learned by working on CHAP that other people might be able to adopt in their own chaos practices?
I think the most important idea is minimizing blast radius. So minimizing that customer pain and focusing on safety to an extent. This will also help you get adoption too. People will be more likely to use chaos if they know that it's not going to run rampant and destroy things, right? It will stop itself if it detects too much of a deviation between what's expected and what it's actually causing. So I think that's the most important aspect people can take from CHAP. The way it works is it actually uses canaries to form an experiment and control cluster. And we actually inject failure or inject the latency into the experiment cluster, and then we watch the control cluster. And so that's what we're watching to see if things deviate. But depending on the type of business you have or the technology you have in your companies, you may think of a different way to do that. But that's how we're approaching it right now.
Okay, so that begs the question of where do you start? Where do you pick that first point to begin to start injecting failure and test the system out?
The shopping cart that you brought up sounds like what I would refer to as a tier one or critical service, meaning that if it goes down, it means dollars lost for the business. It's a critical thing. Engineers get paid straight away. The time to resolve should be shorter. So I wouldn't start with the tier ones right away. I would start with the tier twos and seeing what the fallbacks to these shopping carts are. If those are failing, then that's bad. If those cause the shopping cart to go down, maybe they're tier one and we actually didn't even realize that they're tier one. So there's a few different routes you can go there, but I would start by asking like what the biggest impact is, where most of the issues are happening right now, and try to dig in a little bit deeper there. But I think in terms of injecting failure and latency between calls, I think that's a good place to build your program around. But terminating instances at first to see if you're resilient to that is a great first step. And especially in terms of getting people used to it and getting the chaos team used to it as well.
Okay, so I have another question then. Particularly in your kind of early days with Jet, when chaos engineering wasn't the discipline, the discussion wasn't as it is now, largely because of places like Netflix. You obviously had to have a lot of pushback from engineers when you're like, hey, I know you've got this timeline to deliver some code. I just need you to add a little bit more code on top of what you're already doing to do this, so that way we can, inject failure. How did you win that argument?
Yeah, so at Jet, we were terminating instances at first. So we were doing graceful restarts and ungraceful restarts. So at first, it wasn't a thing that engineers had to get involved in, which I think was important. The most they had to do was opt out of something or clean up something at the end.
Okay, if the developers were easy, your business owners couldn't be easy. You had to have people come into you at least and asking you to turn off the experiments, right?
There were times that I had business owners or service owners come up to me and ask me to turn off the chaos because they had a big release happening that day. And that's when I realized I needed to start changing the conversation around chaos engineering. I realized it was being seen as a blocker and a hindrance rather than something that was a very, very important part in the development process, right? If you're services aren't resilient to a single instance failure, then how are they going to be resilient to the many, many more types of failure that can occur when it's in production? After that road to acceptance, which took a few months, right? It took a few months for people to get used to it and sort of develop around it. And then we eventually didn't really have anybody opting out anymore. At first, we had a lot of people opting out. Then we started focusing on what I like to call targeted chaos. So we looked at our most critical components of our system. So Jet had a huge reliance on Kafka at the time. And we were using Kafka to do regional failovers too. And so we realized if there was an issue with Kafka and there was an issue with how we were using it, things might go really bad. And there was a lot of potential for things to go really bad. So we said, what is the steady state that we want to achieve with these regional failovers in Kafka? And if that steady state gets out of hand, what do we expect to happen? And so that's how we started chaos testing with Kafka. We would change offsets to an extent. So if it was pointing to a particular point, what happened if we changed that point? How would the failover go? would the databases get out of whack, sort of causing them to get out of whack on purpose, feeding them bad data, dropping random packets. So that was the targeted chaos that we started really focusing on at Jet. And since I've left, I know they've been expanding it a little bit more. Netflix is hosting a chaos community day in a couple weeks, and we have people from Jet and people from all over the place coming to talk about what they're doing in terms of chaos engineering at their companies. And then we also have people that are just looking to get started. So I'm excited to see how Jet has continued that in a couple weeks.
That's really cool about the Chaos Community Day. Tell me a bit more about it.
Yeah, so Chaos Community Day, it's a third year it's happening. I went to it as an attendee last year, and this year I'm helping plan it. It's a community-driven event, so it's completely free, and people have the chance to get up and share their stories for 20 minutes, for 5 minutes. It's an invite-only event where people that are practicing chaos or people that want to start practicing chaos all get together and share their stories. It's a fairly small group. Hopefully we'll expand it. Last year we had a lot more interest this year than we had planned for, which is a great problem to have. But I'm very excited for it. It's happening in San Francisco this year. Last year it was based in Seattle. And then I know David Hussman from DevJam is actually planning a Minneapolis one in November.
When is it?
San Francisco one is September 8th.
What's next for chaos? Where is the state-of-the-art moving?
I think it's moving more and more towards automation and having this sort of be a regular thing. Peter Alvaro gave a talk at Velocity San Jose in June about how it can't scale with an expert being involved in the experiments all the time, right? With a chaos engineer, site reliability engineer being involved in helping create every experiment. And that's something that we're recognizing too. I think in its beginning stages, I think it's helpful to have someone there that is explaining the chaos and helping get adoption. But I think once you have buy-in, I think making it more and more automated is the way to go.
So I think that's a super interesting point. Not everybody has the engineering resources that Netflix has. Not everybody's going to be able to have the kind of investment to be able to have a chaos team. So how do you automate and create these, I guess, scenarios in such a way that a developer who's working on some other product line can say, yeah, I should be able to handle this? What does that look like?
At Jet, chaos engineering wasn't my main focus. It was one of my, six focuses. And so I didn't have all my time to dedicate to spending on it, to automating on it, to expanding upon it. I think it's important to really, really monitor it and see how it's going. Monitor it in terms of both culture shift, like how is the tool actually impacting the development process? How have things changed? And also monitor like the business metrics that I was talking about. How is it impacting the business metric to an extent? Is it reducing the number of outages you see in production at 2 a.m.? So those kinds of things. And recording those success stories and monitoring them appropriately will allow you to spend more time on that as you get more success out of it, right? It's in the company's best interest to continue down that path if it's something that's saving them money at the end.
What is it? Lamport's definition of distributed systems that said something like distributed system is one in which the failure of one component or computer you didn't know existed can render your entire computer or system unusable, something like that? There's another part when you were talking about designing experiments that I wanted to ask you about, and it was notify the organization. That's easy, right? Just send an email.
It depends on how you communicate in your organization. So I think it's important to actually know your culture. Some people, I think, have a lot of buy-in for chaos engineering and actually have the ability to sort of say, no, this is what we're doing. We are doing chaos engineering. At organizations I've worked at, that's not the case. I have to actually get people involved. And so if chaos engineering is brand new, I would over communicate everything. Because if you start running rampant and things go wrong, which as the chaos engineer, you're hypothesizing too, you don't know its benefits before you run it. So if things go majorly wrong and you haven't told anyone, the chances of you being able to do this again are going to be very, very low. So it's also important, if you are running your first major experiment, I would actually recommend getting people in a war room, getting a few major service owners in a war room and watching and monitoring when this experiment is actually running.
That's actually what I was going to ask. I was being facetious on the email. It's what do you recommend to really communicate this to an organization when you first kick off? Because there are a lot of people out there that are listening that that obviously aren't running these things are doing it in such a way that they'd like to grow it. So an idea of how you should communicate and how you should get everybody on the same page is a great suggestion.
Thank you, Nora, for taking the time to chat with us today. I learned a lot, and I love the rigor and discipline you all at Netflix are adding to chaos engineering around really changing and defining the discussion, how the practice is performed. Thank you also for being so active and sharing your experience and suggestions with it, folks at QCon. If I remember right, your last QCon New York talk was Choose Your Own Adventure, Chaos Engineering.
Yeah.
It's like 97, 98% green. It was an awesome talk. If you like what you heard and you want to hear more, look for Nora's talk from QCon June on InfoQ. Check her out at Chaos Community Day or look for her at any of the many conferences she's active with. And of course, check out her Chaos Engineering book where she talks about a lot of the things that we just talked about in a bit more detail. Nora, thank you again for taking the time to chat with us today.
Thanks, Wes. It was fun.